let's take a look at how a digraph represents a relation, a subset of V cross V, where V is the vertex set. Okay, we're actually going to think about this in terms of a function. Okay, we're going to let arrows, like this arrow right here, be like a binary operator of sorts, and its input's going to be ordered pairs of vertices, and the output is going to be, this is funny, so this is like a function arrow in the definition, and this is actually the name of the function we're dealing with. Okay, so we go to false and true. Maybe we'll make 0 be false and 1 be true, okay? So kind of what we're after then is the subset we're thinking of is the preimage of 1 for being true. Okay, so let's see kind of how that works. Well, let's just try this. V2, V5. Is there an edge that looks like V2 to V5? There is. That means the output of this, see, we're inputting two vertices, this one and this one. That's like an ordered pair of vertices. So we have this function. If we put in V2 comma V5, we output true, which would be, we'll call it 1, okay, for true. All right, so the output of V2, the ordered pair V2, V5, is 1. So that means that V2, V5 actually live in the preimage of true, the preimage of 1 here. So we could say this is an ordered pair V2, V5. Okay, and then actually we can see exactly which ones are going to be in the preimage precisely by which ones we actually see, which arrows we see here showing up. So we have V4 to V2 is another one. We have V2 to V1. And V1 to V2. And let's just erase this right here for a second. Okay. And so V1 to V2, V2 to V1, and then we have V1 to V3. And that looks like 5, right? There's 5 edges. Okay, so that's it. So, and then the complement of this, meaning all the ordered pairs V cross V that are not in here, would be output false. So for instance, even if I just change the order of 5 and 2, notice there's no edge going back between there and there. So this function right here would read, if I put in V5 comma V2, it would output false, or output 0. Okay, so in that way, the arrow right here is like a binary operator. You put two things on either side, and it outputs something, true or false. But we're labeling those as 0 and 1. And then the preimage of true, or 1 in this case, is a collection of ordered pairs of V cross V, which is a traditional definition of what it means to be a relation simply on a set, simply just a subset of the set V crossed with itself as a Cartesian product. And that's just a little description of how a digraph represents a relation. Thanks for watching.